We are getting started with a panel on sometimes elementary math circles or primary level math circles for small children. We can do this with very young children, and sometimes it has interesting special interest. And so we will let the panelists begin.
And does it matter to you with the technology who starts? Are you?
No, I've got the Talking Stick blog up if you want to.
We've got the Talking Stick blog up. I'll start. So my name's Rhodey Stein. Actually, if it's all right with you, I'm going to stand here, and then I have a loud voice, and then I can try to be facing everyone. Is that
awesome?
Or does that cut off my head?
You're fine.
Anyway, so I'm Philadelphia. I run a math circle at Talking Stick Learning Center, and I want to talk to you about 4 things quickly. I want to mention a blog that I write, which Dave has up on the screen. I want to talk about using storytelling with children. I have a list of 8 sort of lessons I learned pedagogically about teaching, and talk to you very quickly about a couple challenges that I face. So number 1, every week when I do my math circle, I go home and I write a report to the parents of the kids of exactly what we did in incredible detail, because I want them to know that they're getting their money's worth and their kids are really doing something, and also it helps me process my thoughts. So I do publish that. That's a picture of the blog up there on the TalkingStickLearningCenter.org website, and I send it out to some email listservs. And I'd like for people to read it, because I've gone through an incredible amount of work putting these things together, and I hope that there's some kind of economy of scale that other people will use things that I'm using. But also I'd like for people to read it, because you might see something that I'm doing and say, oh wow, we did that, and it was so interesting when we went into blah, 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 and then maybe you'll email me with your ideas about where my math circle might go. I'm pretty new at this, and I'm always looking for content. So I also talk a lot about pedagogical reasons why I do things in the blog, because as I'm writing it, I have in mind that my audience is parents of kids who are in there, math educators, math circle leaders, and even prospective parents. Maybe we use it a little bit for marketing as well. So that's the blog. Every week, again, there's a report and a picture. One thing I use a lot in my math circles with the youngest kids, especially, I do one for 6 to 8-year-olds, is storytelling. I want kids to really feel a need for the math that they're doing. And older kids can sometimes feel the need intrinsically or historically or related to something that they're doing in real life, but younger kids a lot of times don't have that. So I'll usually start out with a story. So for instance, once I wanted to do a problem that I've heard referred to as the dark bridge problem or the light the bridge problem. And it's a problem where there's a bridge and 2 people can cross at a time, and they need a flashlight, and only 2 people can cross, and it has to be done within 17 minutes, and one person can do it in 1 minute, and one person in 2 minutes, and one person in 5 minutes, and one person in 10 minutes. So that'll be fun to look at with the little kids to see if they can figure it out. But I wanted there to be a reason for it. So I told the kids, there's a unicorn dying on the other side of this bridge. And it's in a magical world where the only thing that will save the unicorn is if these exact 4 particular children stand around the unicorn in a circle, holding hands, and say a magical spell. And if they don't do it within 17 minutes, the unicorn will die. And it's night, and there's the bridge, and there's the one flashlight, and these are their raids, blah, 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 blah. But it got them excited to try to save the unicorn. And it turns out it was a really, really hard problem for kids of that age. It took weeks and weeks and weeks for them to get it, but they were so excited. Every week they were running in, are we going to save the unicorn this week? So for almost every concept, I'm trying to have a story, and some of those stories are on the blog, and I'm always just trying to think of more stories for things. It's really actually kind of fun. So that's what one recommendation I guess I would have is it's just been really successful. And with the older kids, having there be different kinds of stories too, but maybe not like that. Some of the challenges I've faced, I've got 3 major challenges. Number 1 is coming up with content, because I'm pretty new at this. Although again, I'm hoping people will email things. And I email out to the Math Circle community all the time. I'm going to do this and I'm going to do that. And so many of you have helped me. So thank you for your ideas that I've been using. Another thing is just the amount of work it is, because we have this Math Circle going at this place and I'm the only person leading it. And I have really 3 different age groups of kids where the parents want there to be Math Circles. 6 to 8-year-olds, older elementary school, like 9 and 10-year-olds, and then middle school. So I've been trying to do all 3, one after the other in these short sessions, and it's a lot. So we're hoping to get another leader or 2. So that's something that if anyone wants to come up with advice for me at lunch, I'd appreciate. Yeah, just the amount of work it is being the only person doing it. Other things I wanted to share with you are, I came up with a list of 8 things that I thought were really important for me in leading these Math Circles that I thought I would share with you. And some of these you already heard today, so I'll be brief. So number 1 is practice detachment. I can get really attached to my own agenda of what we're going to study in this Math Circle. For instance, once I did this whole entire flow chart when I was planning to do the platonic solids with the 9 and 10-year-olds. I had a flow chart with every direction it might possibly go, and all these interesting things we could do. And they just couldn't get into the platonic solids at all. So I said, okay, and we went into the thing they were interested in, and they all had a great time and still learned a lot of math and learned the inquiry process and all the Math Circle things that we're trying to do. So I'm trying to propose things, put questions out there, but go along with the direction the kids want to take it. Number 2 is an idea I've heard referred to as the beginner's mind. The beginner's mind is, if you're experiencing something, still try to see it as a beginner and see it fresh. For me, that also means, first of all, I don't always have to go into the Math Circle with the question that I know the answer to. Sometimes I've gone in intentionally not knowing the answer and just kind of explored it with the kids. And that's kind of fun. Also that it's okay to lead Math Circles not being a mathematician. I've heard a lot of people tell me over this year, oh, I'd love to learn Math Circles, but I just don't know enough math. I'm not a mathematician. Well, I'm not a mathematician, and I'm learning it with the kids. I had a lot of math in college like 30 years ago, but I don't even remember it. The other thing with the beginner's mind helps me to remember to do is to pick topics that are interesting to me. When I'm learning, what am I going to do with them? It's like, just like poke around on the internet. I'm like, that looks really cool and interesting, fun. If I think it's fun, hopefully they'll think it's fun. And so far, that has worked. All right, number 3 on my list of 8 is just listen more. When in doubt, shut up. Don't say anything. And the kids will come up with something or say something. Number 4, and it's kind of related to the storytelling, but especially with the older kids, once you're at the 9 and up, is include things besides math. Every time I'm trying to include something from history. It could be a biography of a mathematician or some historical event that's relevant to what we're talking about. Or a piece of poetry, or a piece of art, or even something from music. But there are so many things that are tangential and relevant that make things come so much more alive for the kids. Number 5 is let the kids move. I find that if I want them to sit around the table, they don't want to sit around the table, and I have a power struggle about it, but if they want to lie on the windowsill or sit on the floor or stay on their head in the corner, as long as they're participating and engaged in the mathematics, and not disturbing anybody else's learning experience, I'm fine with that. And they have a lot of fun that way if they can get involved with their bodies as well. Number 6 is to repeatedly find ways to point out to kids that mathematics does not mean arithmetic. So many of the kids that I see just come in like, I'm not good at math, I'm so bad at math, and they even come in with these ideas. Even homeschoolers, probably 2/3 of my kids are homeschoolers, but kids are just like, I don't like math, I'm not good at math, but what they're really talking about is computation. So the more I can point out to them that this cool thing is math and that's cool thing is math, that they didn't even realize is math, they can feel encouraged and confident across mathematics. Number 7 on my list is having different avenues of engagement into math in a given math circle. What I'm seeing, and I'm sure a lot of you know, is that everybody comes into mathematics differently. Some people have a more graphic, geometric approach to things. Some people see things numerically. Some people see things logically. Some people see things in ways that I don't see them, and can take different avenues in and kind of still get to the same place. So to be open-minded about that, provide opportunities for that. For one example is, we're right now in a middle school math circle, and we're using different videos by Weihart. So one thing that's came up right from the start that a lot of the kids are really into is Sierpinski's triangle, which is a fractal. And it's a pretty geometric kind of thing, but you can also come at it through algebra, through numbers, through geometry. And I have this one boy in the class who everything through numbers, no matter what. And he's the only one. The rest of them are all way more graphical. But he's there doing the exact same thing as everybody else, but just with numbers while they're drawing and coloring and discussing. And we're all still doing what we're supposed to be doing, even if we're not all doing the same thing at the same time. I have another boy in that class who's a little younger. He's 9, going on 10, and his younger sister had been in a couple of the circles, and his mother was there working in the other room while I'm there. So it turned out all year long, he had been in a building around the corner, looking out that window, in our window, at our math circle, saying to his mom all the time, "They're having so much fun there, I have to join, I have to join." So his mom said, "Could she join?" I said, "Sure, he's a little young, we'll see if he likes it." So he came in there, and for the first couple of days, he was drawing monsters. And I just let it go. I knew he was young, I knew he was listening, he wasn't disrupting or anything, but on the 3rd or 4th day, he came up to me with his notebook, and he says, "Look at this fractal I made." And I think it started out as a monster. And do you think it will continue infinitely if I get smaller? Do you think it will continue this? Like he was so with it, even though it looked like he was just drawing monsters. So just the idea of giving kids the freedom to explore the math the way that feels good for them has been really successful with the kids that I have. And then my last one, number 8, is just to have fun. It's so much fun to hear the way kids are thinking about things and the way they're looking at them, and sometimes even the funny things that they say. So I'm going to end with something that somebody said last week that I thought was pretty funny, and some of you might have heard this already. We were talking about the mathematician Sonia Kovalevsky, and I was telling her life story, and we got to this part where she entered this math contest, and it was anonymous, and no one knew it was a woman, but she put in this entry, and it was so outstanding that the judges decided to raise the prize from 3,000 francs to 5,000 francs. So one boy in my class who's 11 said, "You mean they paid her in hot dogs?" I almost laughed for the rest of the class. It was such a joy to hear these things. I'd never seen there's something like that. So, of course, we went off into a tangent on currency and how it's different in different places and the math of that. But that's what I was going to say. I love that.
So, maybe Bill Mueller?
I don't have anything prepared. I was just kind of here to answer questions.
Well, do you want to say a little bit about your circle, and then you can answer questions?
Sure. So I've been running a small elementary circle for kindergarten through 5th graders in Rockport, Massachusetts for the last 3 years or so. We keep it real simple. We do a lot of the things that Rhodey was mentioning. You know, our math circle is free. Kids can come and go. Every week is different. There's no continuity from one week to the next. So that makes it very easy to run. Pretty much, I just have to have an idea, or one of the other parents has to have an idea. You know, we're constantly throwing things around. And you know, we put together a few slides to introduce the kids. We come up with, you know, 1 or 2 activities, and we want them doing things most of the time. And we don't really plan anything more than that. We go in and we do it, and whatever happens, happens. You know, sometimes it works, sometimes it doesn't. But it works well for us because, you know, all the parents involved are working parents. You know, I'm a working parent, and so, you know, we can't spend a lot of time doing administrative stuff or evaluating what we did. You know, our goal is really just for the kids to come in, have fun, and say, you know, this is math, you're doing math, it's fun, right? And we all go, yeah, you know, so if we can do that every week, that's a success. So I have a long list of different activities that we've done. I'll just mention a few of them here. I'll just sort of go down the list here that I have on my computer, and I'll try and get these up on the website. I do have to say that the restriction to just one PDF file is a little
That will be changed in about 2 weeks.
okay.
We upgraded
If I could upload arbitrary files, then I'd be able to share a lot more of
Yes.
what we've developed. We've done algorithms and flowcharts, we've done angles and triangles, binary numbers, bubbles, circuits, codes, continuity and discontinuity, counting by groups, dice, flexagons. We did a math magic show, number patterns, optimization problems, origami, outcome trees or probability trees, classifying pasta according to its shape, polyhedra. We did powers of 2 and 10. We've done robots, rockets. We had a parent who loved rockets, so we did positive and negative numbers and position and velocity, and then went out and shot a rocket off from the back of the school with a little altimeter so we could get data and look at it. Set, this game Set that I think a lot of you know is very popular. We play a lot of games. We have a lot of board games that we'll play. Shadows and Slices, we did kind of Flatland sort of stuff, and then at the end we watched the movie, the Flatland movie.
Which one, British or American?
The new one, the American one. Spirals, Spirograph. I don't know if you know that old Spirograph toy. I have about 6 sets of them. We've done different things with like random walks, Sudoku puzzles, tangrams, visual patterns. We do a lot with art and music and looking for patterns and things like that. We try and bring that in, and bring in a lot of historical, just like maybe a slide or some sort of historical background for things like that. Zone Tool, we use Zone Tool a lot for building all sorts of things. So those are just some of the things we do, and it's just kind of like one-off ideas that, you know, it comes to be. We do our math circle on Saturday. On Sunday, I usually try and have some idea about, you know, what we're going to do next week. And, you know, I try and, like, during my lunch breaks during the week, put together, you know, what we need to do, and then we run it on Saturday. So that's pretty much the way our circle works. And I'll try and get these materials up maybe over the summer if the formats can be changed.
The website's getting much better. So Laura, would you like to?
Okay. I'm involved with my elementary math circle in Berkeley, Stanford, and Marine. Originally started with Natasha Roskovskaya, who came to Berkeley with her small son, and she decided that, you know, why not try to do something there. And it was 3 years ago, and it's the end of the 3rd year that we are doing that, and it grew from Berkeley to Marine, and then from Marine to Stanford. And I think currently we have approximately 125 small kids in Berkeley, and half of them are in grades 1 and 2, and half of them in grades 3 and 4. Then in Stanford, it's approximately 90 kids, with 52 in grades 1 and 2, and 28 in 3 and 4. And in Marine, it's 28 kids in grades 3 and 4. So now we are all stretched out. It's impossible to actually get more circles, well, at least for our group. And the problems that we have is, and we are trying to solve them one by one. First, we had the kids in grades, actually from kindergarten to the 3rd grade, and it's really a big difference in their knowledge and what they know from the kindergarten to the 3rd grade. So this year we actually split them into the grades 1 and 2 and 3 and 4, and it's actually much, much better. Of course, you know, it would be ideal to split them by grade, but it doesn't work. You just can't do that. Then, how do you select the kids at this age? They are mostly pushed by their parents. You have occasionally kids, like I had an email where parents wrote that their kid is 4 years and a half and he dreams math. So, and they are just have nothing to do with math, so what to do? And they actually asked us, though we don't take now kindergartens because it's too early, but they asked us to take the kid, and we took him, and he was the best kid we ever had. He actually, it's not that he could do the problems, but the way he formulated his thoughts was on the level of the 5th, 6th grader, and a good one. So how do you select them? Because, occasionally we get big emails how great the kids are, but they are not. At this age, you can't give them problems. They're young, they're shy. It takes them 2, 3 sessions to actually start talking to us. So it's difficult to select them, and then if the kid comes, it's really difficult to send him away, unless, he's destructive. And we actually do not have kids like that, almost none. So then again, we have a huge wait list, and right now that wait list is so big that I don't think that a lot of kids will just get at any time into the math circle. I don't know what to do with that. So I think next year we'll try to select the kids. We ask the parents to write a small abstract. Why do they think their kids need the math circle? And we'll try to do something like that. We don't have the experience with that. We don't know what will happen. But at least we'll try to pre-select them. The most difficult part is actually to find the materials. Because, our goal is actually select the materials that are mathematically meaningful. And it's not just a problem solving, but we would like to really introduce them to different aspects of math. And with that minimum knowledge that they have at that age, what do we do? So the topics, well, sometimes the classes are great, sometimes they are not that great. Something, we thought would be great comes up really badly. But what we tried and really worked for us, it was combinatorics. We did a few sessions with that, and it really works with small kids. We did areas, and actually we showed them and proved them, and they really understood the area of the triangle. And after the lesson, there was one parent who came to me and said, "Thank you. I always knew that the area of the triangle is the base on height and divided by 2, but I never knew why, so you explained it to me." And actually, we do have things like that from the parents who are sitting there. We do some geometry. This year we had like 5 or 6 different classes on symmetry, and we actually showed them that there is more than line and mirror symmetry. There's rotational symmetry and translational symmetry, and how you can flip the color and actually combine the symmetries. And actually kids really liked it. Just telling David yesterday that I think he came up with an alphabet where we wrote all the letters and said that, let's say there is a girl, Mary, who came and split the alphabet into 2 groups, and we put all the symmetric letters in one group and another group are not symmetric. We don't do that to kids. And then Anne came and split the alphabet into 4 groups, and then we split them into the ones that have 2 lines of symmetries, the ones that have rotational symmetry, and the ones that do not have symmetry, and asked kids to figure out what was actually going on. And they spent some time, and after that, really we discussed, they thought that letter S and N, they are mirror symmetry, and we were trying to explain why not. We experimented with that, and after that, really, in 3, 4 classes, I think now they can answer, what are symmetries and what different symmetries, and so on. One of the best things that we did, and I don't know, there were some things that how we managed that. we looked at how many parts and lines will split the plane, and we explained that to the kids in the first and second grade. And we started about a few lessons before telling them about the triangular numbers. And then, you know, we experimented with the 1 line, 2 lines, 3 lines, created a table, and then kids started recognizing that, you know, the results are triangular numbers plus 1. And then we drew the 4th line. What us really helped when we named the lines like Ann, Bob, Charlie, and then the points of the intersections with letters and colored the pieces of the intervals on that line. And after that, they actually really, in a way, proved for them, you know, what will happen next. And we told them that that is the real experience of the mathematician, you know, like first guess, then come up with some idea, and then prove it, and they were so happy about that. So the question is what to do next. You know, definitely we can't grow more, at least, you know, the way we are now, because I think the preparation for each lesson takes 3 of us, probably like 20 hours at least, discussing and looking at, you know, how and where we want to go. And then a lot of lessons. So I don't know, I would love some ideas how to grow. And how to pass that experience, at least in our area, so somebody else can do that.
Write it down, post it online.
Get more
No,
help.
but you know, the problem is that I don't believe that anybody can take these materials, just go with them and have a math circle. I don't believe that you have to have that learning curve. You have to have your own ideas. You have to try your. And I'm not sure that it's easy to actually just print the materials and then say, okay, go with that.
I think to this question of how we can increase the number of participants and how we can potentially grow, there is a way actually which will not change your structure that much. That's what we're doing in the Los Angeles Math Circle. In addition to having faculty or teachers or, in short, adults who teach children, we have an intermediate step where we train undergraduate and graduate students. And so we have altogether 8 groups for kids from first grade. Actually, we have a kindergarten, so from K through 12. And in every one of these 8 groups, there are some graduate and undergraduate students, and some of them participate for years. So they're meeting with me, and we go over the curriculum together. Sometimes we construct curriculum together. And at the very least, those who are just assistants, they have to come prepared. They go through the problems. We talk about philosophy and all of that. And even after they graduate, some of them choose to continue being involved in things related to math circles or other activities where they involve young children into mathematics. So in a way, this is what makes us spread and grow. One example is sitting right here. Shannon was in the Los Angeles Math Circle maybe for over 2 years. So she started as an assistant, and then she was a group leader for actually an early elementary circle for students in 2nd, 3rd grade at the time, and now she works for problem solving, and she has her own wonderful ideas, developed curriculum, but I hope that you took something from us.
It's definitely the start.
And we had graduate students who graduated and went to work in summer camps and do other wonderful things. So it's not growth on the spot, but it's growth in time and in space.
I forgot to mention one more problem. We don't have rooms in UC Berkeley. You can't find rooms to fit the kids. You have specific size rooms for the tables to fit
We
the
have
kids.
the same problem, but adding a few adults who are floating around, adding a few undergraduate and graduate students who are floating around.
Yeah, that would be nice.
So that's
Renting a classroom in a school is really cheap.
that's
Well,
But and you also
it's
have
not the question of that. You know, you have a Berkeley Math Circle. It's a huge thing. And there are a lot of kids who are siblings out of those. And it's convenient for them to come at the same time, at the same location. And, you know, again, if it's in Berkeley, it's central. So everything is possible, but it's not that easy.
So-
as for the teachers, I was thinking you have so many high school math circles in the area, and those kids are they already know what mathematical circle is. They already know what to expect from a mathematical circle. So when you take an undergraduate student who has no experience with mathematical circles compared to, say, a high schooler who has an experience with mathematical circles, it may be easier to, recruit those high schoolers. Think of that. And they're really good with little kids.
And
Little kids really enjoy working with them.
this is a wonderful segue to our final panelist, who happens to be one of these students who was a math circle student who is working. So do you want to drive from up here or sit there and have us? So, here, projector she's going to have, and I will go rogue again.
Right, so we're all fancy, we have a PowerPoint. Alright, so out of inquiry, we're a logic and math thinking circle. We're teaching a 4th and 5th grade group, and this year will be it has been our first year with teaching our own class with our own curriculum. So we'll be going into a little more detail. So we'll be going into a little more detail about some of the classes we've done. So essentially, our class structure is, when the kids come in, we're going to shoot an entry problem at them. This often has little to nothing to do with the rest of the class. It's just to get their brains working, just something fun to get it started. And then we'll sit on the rug. We'll talk a little bit about whatever we're studying for the day, do some problems, come back to the rug, and just kind of get their brains going. So this year we've covered a few things. This is broader groups of things.
Yeah, so we sort of try to choose a couple things that people don't normally do really in their sort of the math they do in the normal public schools, because I mean we've both been through the same public schools. So we've done things like the arithmetic systems like postfix, infix, prefix that people normally just are never introduced to unless they go to something else.
And we'll go into a little more detail on a few of those. Right. So near the beginning of the year, we devoted a couple lessons to the concept of proofs. So to show that, so when we're starting out with that little unit, we lined the kids up to show that axioms are necessary. So we had Marie on Eva's shoulders and Eva's shoulders on Vicky's shoulders, and we'd say, okay, so she's proving her, and she's proving her, but what's proving the first person? So that kind of came across that you need axioms, you need to assume a few things to show where math comes from. And we did some more complicated stuff.
So yeah, we did a lot of geometric proofs, like that one up there. It's sort of like a proof that the smaller square in the darker blue is like, what, half the area of the square in the lighter blue? I mean, you just sort of fold the triangles in. The kids sort of like those. And then we also did some more sort of abstract proofs, and we managed to spend about 30 minutes on a proof of infinite primes, a sort of proof of contradiction, and that actually worked out pretty nicely.
Yeah, it was a very pleasant surprise because these are little kids, they're 9 and 10-year-olds, and it's a pretty abstract concept. But in the end, we went through it a couple of times, and I think most of them got it, which was pretty great. So then we spent a few lessons on things vaguely related to sequences and series of different types. So the first thing, everybody might want to take a few seconds and think whether they can continue that. It's not a very simple thing. Right. The solution is actually that it's got nothing to do with arithmetic. You simply read it out. The first term is 1, 1. So the next term is 1, 1. The second term has 2 1s, 2, 1. Then there's 1, 2, 1, 1. And so on. And of course, the kids spent ages on this, couldn't figure anything out, and loved it when they got the answer. And then we went on to a couple more mathy things.
So yeah, we did sort of Gauss's formula with like the sum of the first n integers, positive integers. And then we also did this thing called Messner's magic, which is up on the, I guess, PowerPoint, where you can just get the sequences of the squares or the cubes or anything, the like perfect fourth powers if they have a special name. But they weren't really excited about this. Some of them were sort of vaguely interested, but there's too much. A lot of it was a lot of sort of arithmetic involved, and sometimes there's a lot of math, and that just sort of really turned them off, and they weren't entirely interested in the whole math and abstractness.
So I mean, it's a pretty cool thing, but just the numbers at this age just boring.
So the next unit we did was this sort of mini unit on game theory, and that we did one lesson on game theory. The first one we had a couple of activities that to do. The first one was the ultimatum game, which is basically there are two players, and then one player is sort of the like boss or overlord or whatever. And I say, I decide how I want to split 10 points. I can say I want to keep all 10 points, or I can say I'll let you have, like a point because I'm feeling nice. And she can either accept or reject. If she accepts, then we both get the points we get. If she rejects, no one gets anything. So, I mean, basically what I guess sort of should happen is that I would offer 9 points for me, 1 point for her, and she would accept because 1 point's better than nothing. So, and the kids had this like weird idea of fairness or something. So a lot of them actually offered 5 and 5, and but there were a couple of kids who did offer 9 and 1. And then the next one was the all too famous Prisoner's Dilemma. The kids loved that. There were lots of cries of, "But you promised me that you wouldn't like betray me." So if anyone doesn't know what it is, it's pretty famous. So the next one we did was this special type of auction of 50 points, where not only, so you would bid just like a normal auction, and then the highest bid had to pay their bid, and also the second highest bidder had to also pay their bid. But the second highest bidder didn't like get anything in return. They basically just lost whatever they bid. And so what happened is that, usually happens is that the two highest get just trapped into this cycle. If I bid like 39 and she bids 40, then I want to bid 41, because that way I'll get 9 points as opposed to losing 39 points. So it just keeps on going until one of them just runs out of points to bid with.
And it goes well past 50. Apparently, this was conducted on Wall Street at some point to see what would happen when you did this with real bankers, and they ran into something like $700 because they just wouldn't quit, which makes it worse for everybody. It is interesting because in this case, with games a lot of the time, competitiveness is a good thing. But in this case, two of the most competitive kids in the class got trapped in this, and we're both pretty unhappy afterwards. So there were a lot of interesting thoughts there while we were doing it, and everybody had a lot of fun. But we kind of ran out of time to talk about the deeper thoughts behind the game theory, but they probably learned a lot anyway, and I know they enjoyed it. Right.
So,
and then we spent
show
several
to the
classes
videos.
talking about things related to infinity, which was very interesting. So first we started out with variant of the hotel infinity story. If anybody's not familiar, that's the hotel with an infinite number of rooms, and each room is occupied, and oh no, one more person arrives. How do we accommodate him? An infinite number of people arrive. How do we accommodate them? Or if we go all the way to the end to get a chocolate bar, then bring it back. How does that work? And we were actually, it was very interesting because we expected them to be really against the idea of every room is full. No, that can't happen. It's infinite. And surprisingly, that part they were comfortable with. And then later on, though, it's like, what do you mean? How can you double the room number when you accommodate an infinite number of guests? And it's just, well, if your room number is 2, you go to 4. If your room number is 2,000, you go to 4,000. And some of our kids who are really abstract thinkers in general had blinked on this and just were, but infinity is just the biggest number, right? So then if you get 2 infinity. So yeah, that was quite interesting.
Do you like the video?
Sure, yeah. And a little later on, we were talking about the expansion of the universe, so a little thing about how kids see infinity.
Up at the very top.
It's just the first 12 seconds.
No volume.
There you go. Just keep going up.
Because it's constantly expanding. So you can figure it out by it.
Yeah. So that's it. I've got a little more on math.
So it's easier to process. Right now, you don't really know
That's
enough
enough.
math to do
That's
this.
enough.
But in a few years, and if you do some research.
The guy's question there was basically, how would you know the size of the universe if it's always expanding? Like, how would you know at any given time how big it was? So, I mean, that was an interesting question.
So, did you explain the redshift?
To the nearest edge.
No.
No, but it's just an interesting thing about how kids see infinity. we might have gotten a little bit into the redshift. But
So how did you guys answer that question?
These sort of things.
Oh.
We sort of
Not
just
every
said that
question
you don't
needs an
really
answer.
have the right knowledge or the right level of thinking to really understand.
But let's write like the speech of a car or a train or how it.
Yeah, I mean, we were really talking about astronomy.
Yeah.
And there's nothing wrong with leaving a question unanswered. It makes them more curious.
Okay.
So the next sort of thing we did was sort of infinite series, and so these weren't like real infinite series. Like I think there's some infinite series over there, like 4n over whatever, some ridiculous thing. Ours was more like what is 1 plus 1 plus 1 plus 1 all the way, and they were pretty comfortable with that. They were just like that's infinity. Now what about this like 1,000 plus 1,000 plus 1,000 plus 1,000 and so on? They were comfortable with that too. That's infinity. Then we did this 0 plus 0 plus 0 plus 0 plus 0 all the way on. And there was this we got into this 30 minutes just bitter controversy about whether it was 0 or whether it was infinity or whether it was just nothing because it didn't really exist. And that was a very interesting conversation. Kids just refused to believe that it would be 0 or that it actually really mattered anyways. Because
anything with numbers more complicated than that, like once you get to 1/2 plus 1/4 plus 1/8, nope, too much math, not doing this.
Yeah.
They get upset.
Fractals, we also tried to do some sort of thing on fractals, and it did not work out too well. We tried to start with the coastline paradox, and they just sort of did not get it from the get-go. Like everything, they did not understand why if you had a smaller ruler, you get a bigger length of the coastline. They just really didn't understand it. So in the end, we just sort of really had to sort of jump ship and change.
It's kind of unpredictable what it's going to go with them and what's not. Even when you know the kids really well, sometimes they surprise you. You go on. And then everybody's favorite is we have, about once a month, we have competitions. And competitions aren't really about any specific area. There can be logic questions or geometry questions. Like there was one nice one where there's a shape like this, and the question shows you can split this shape up into 4 parts, and it gives you this complicated little thing where it's rotational symmetry about the center. And then the question is, how do you split it up into 5 parts? And everybody's trying to figure something out from the center. The solution's really simple. It's just you draw strips across it. But nobody gets this because the previous one sets them up. So that's a good branch into talking about what limitations they have and so on. We have lateral thinking questions, something you might call trick questions, but are valid too. The kids usually love these, and they usually go really well. And the last day of the year, we actually had a scavenger hunt, set out problems all around the school, and had them solving problems and running around to find the next ones. They love that. They love being outside and combining with interesting problems where they don't know how to approach them, which is the favorite. That was good.
So like the couple lessons we just learned at the end was that you should know your class pretty well in order to try to develop a curriculum, but even then it's sort of hard to find sort of a balance between what is sort of too hard for them, what is too easy for them. And even like if one problem may be too hard for part of your class and like very, very easy for another part. Also like when should you sort of nudge them on a little, and when like how much help is appropriate, how much help is too much, and just finding a balance is just generally difficult.
I mean, say we have one kid who gets the math down pat, and if the problem's too easy for him, he just doodles. So other the time, Alan just ends up sitting over there by himself, with this kid by himself, and they're just working something out and making it more interesting. Or I've got other kids who don't really pick up on everything in the class, who don't always follow, but I think they're getting a lot out of it anyway. Because there's still some things they're learning, others are learning maybe a little more, but what's important is that they're all learning something. And of course it's very important to follow the kids' cues. A lot of the times the kids are going to want to talk about something, and if they want to talk about something, they will. It's going to happen. So you might as well make sure they're learning something from it. Tie it in, tie it back to math, tie it back to science. But if they find something boring, there's just simply no point continuing with it. If they find something interesting, that's where you can really go places.
Yeah, another thing we learned was try to keep basically all numbers out of it. As soon as you introduce any number, or really any sort of vague layer of abstractness, it really doesn't work. One of the interesting things I noticed is that some kids would write these equations like 5x plus 1 is equal to 6. and they would sort of understand that like x is a variable. But as soon as you wrote something like 5y plus 1 is equal to 6, then everything is just totally gone. Like, all of their skills are just out the window. It's very unpredictable.
Again, it comes back to what works for them and what doesn't. Although, I was talking to Rodi a little yesterday about whether you need to, at the same time, be weaning them from manipulatives to the abstract, but somehow make sure they understand it in the first place. So there's a delicate balance there. That's something we'll have to work on. And then, of course, variety is crucially important. They don't want to do the same thing 5 times. Like, we had one lesson on function transformations that was essentially, we gave them several graphs with functions and asked them to make certain changes. And to them, they see this worksheet, it's all the same, not fun. They didn't want to do that. So, kind of mix it up. Okay, that's about all we got. Thank you.
We go back to the cameras. So, do we have questions for the panelists or discussion amongst the panelists?
Do you guys plan to go on this pretzels track again? The reason I'm asking is, if you haven't tried this, you know, there is this game which is called Hanoi Tower Puzzle, which is fractal in nature.
We did that once, so they were fun with that. Or even
but you know that the allowed states...
Speak up, please. We don't hear.
Oh, I'm sorry. There is a game called the Hanoi Tower Puzzle, which is fractal in nature. It's very simple. It's also an example of a recursive algorithm. But if you draw the graph which has the allowed states of the puzzle as vertices and the moves as edges, actually these graphs, depending on the number of disks in the game, they give you approximation of Sierpinski triangle, which is a very well-known fractal. And we found that that was something kids could basically, at this age I also work with first, second graders, and right now with third and fourth graders. So, and I think they mostly learn with much more with their fingertips than with their heads yet. So, but since you could move these parts of that fractal around and move along the graph in various ways, that was very visual and very tactile, and that's what we did. So.
I'll keep that in mind. We'll try some other fractals because, like, they like Sierpinski's triangle, and it's just it's the coastline paradox, and the others we had didn't work for whatever reason. So we'll go try that again then.
And what fractals did they like?
I don't know. What did we have? We had the coastline paradox. Yeah. We were going to do several things with it, but then they didn't get the basic premise.
Yeah, they liked a lot of the sort of picture fractals because a lot of them are sort of artistic. So I mean, they like Sierpinski's triangle. They like the Concord. The snowflake with the triangles attached. But, I mean, we didn't really get to be able to do anything more than just see what it is, and then it's sort of pretty looking.
The Cox snowflake they had a lot of fun with, though. I mean, at the beginning of the class, as soon as we introduced this, we had kids running up to us and going, I know what it's going to be a circle. And others running up and going, no, it's going to be a triangle. This was before we even started talking about this. So, of course, there was a lot of debate there.
Some success with doing pop-up fractals, Sierpinski pop-up stuff, because it's something about that idea of the iteration that happens naturally in the actual physical movements, where every cut gets smaller by halves, etc. And it's pretty, and they like to take it home. So.
I have comments about how I've run it in terms of structure. I didn't hear people talk about that, and it's something I came to over the years, and maybe it'll help. This is work with kids from grades about 3 through 7, so not really the younger kids. And I worked in people's homes, so I had to get them focused. So the first thing I would do is do something. I'd move essentially from structured to less structured activities. So I had something first where they had actual problems to give out. And I have to disagree a little bit. Kids love arithmetic because they can do it. If you give them something that they can do and they can get an answer, that's what we're weaning them from, but that's what they're comfortable with. So you start there, and then you go from there to generalizations of names and so forth. A good trick is to put the kids' names in the problems. That the kids everybody loves their own name. We know that. What's his name? How to win friends. But kids especially. And this in many of my math circles evolved into a whole culture where kids took on persona. A persona, and we actually had little skits which had problems in them, so I can show you some. at the end, I'm skipping to the end of say, an hour-long thing. At the end, I always did something that was surefire that they loved to do, like dessert. So they loved to play set. So the last 15 minutes they got to play set. Or they loved to pay 24, which, by the way, you can do with playing cards. You don't need the commercially sold sets. There's certain things they just love to do, and there's nothing wrong with them doing it over and over again, because they're not going to do it in another context. And they learn from it. So that was the end. In the middle is where I put stuff that was like, I was not surefire, I wasn't sure. Like if I were doing fractals, I put it in the middle, and then I do it better the next time. Because first of all, you've got them set already. Second of all, you can always pull the plug and start doing set because you know it's going to work and they're going to love it and they'll forgive you anything that you do. And if you have these things, and then you don't have to have everything tried and true. You can experiment and increase your repertoire because you have some things that are grounded, some things that are risky, and a way to get from one to another. And that worked for me for a lot of years.
Yes, Anne?
One of the problems that I came up with as a volunteer instructor for fourth graders in Orange County Math Circle was that I had a hard time determining whether the level of difficulty for the problems that I made for my students was appropriate. So do you have any advice on how to assess the capabilities of young students?
It gets easier as you get to know your kids. So you're going to be able to say, oh, this kid is going to have this idea and this kid is going to struggle with this. But so as you try to learn that, before you give the lesson, try to plan out what hints you're going to give, how you're going to make it easier. You can make it harder. And just try to have avenues where you can go. A lot of times they'll suggest something. Like, they'll mention something and you can go, that's a good question. How would you do that? And on the other end, you can simplify the problem, cut out the hard part. If they don't get the premise, spend a while talking about the premise. And kind of go with the flow, see what you can do and plan out alternatives.
One thing that I do a lot that addresses a lot of the things that people have commented on is function machines. And function machines are one of those surefire things that kids love. They're also a good way to go from the physical, manipulative, and real into the abstract. And it's a good way to assess what kids know, because you can start out with something kind of easy, and the kids with the lowest ability will have success with that and get harder and harder and harder, so that by the time you've gone through them all, maybe only one or two kids can do it. But then you'll have a good idea of what everybody can do, and the ones who are at, and everybody gets challenged and has fun too.
Something I did for assessment once, I was going to teach some 4th and 5th graders geometry. So I took about 20 minutes the first day and just filled a whiteboard with all the words they knew about geometry. And you'd be amazed at how much you can tell from that, what's there and what's not there.
So, I had two comments related to Dana's and Alan's thing. One was I had done Hotel Infinity many years ago, and had done Cantor's argument for infinities beyond infinities using colored flavored frosting, and it was completely bizarre to the first group of students that there could really be something bigger than infinity. And then I did it a couple of years ago with a group of first grade girls, and they were all like, to infinity and beyond. And so it was no longer such a surprise. And that goes to knowing your audience. Another comment is people can ask me afterwards, maybe one day I'll post it, but to describe the expanding universe, you can do a nice exercise measuring distances between Pepsi bottles and get there, starting with shadows and then going through parallax. And so there's nice manipulatives walking out on the lawn that might work with your scavenger hunt.
Well, speaking of parallax, the transit of Venus is happening June 5th. And that's how they originally, on June 5th, most of the United States will be able to see Venus pass in front of the sun near sunset. We're in from Indiana, and so we'll only get to see an hour and a half of it or so. Hawaii is the ideal location. you want to take the math circle there. But to see the whole thing. But that, you know, Edmund Halley sent fleets out all over the planet to observe the transit of Venus and time it and note its position on the sun, so that they could tell the distance, you know, the locations by latitude give a parallax effect on through Venus, and you can figure out the distance from the Earth to the sun that way. And so the transit of Venus is a big, it's most, they're still doing some scientific stuff, but it's mostly, it was, I think, more high profile before, centuries ago, but it's still really interesting.
But you can do parallax very well with your 2-liter soda bottles. You put one out 200 meters and another one out 600 meters so that they're visible from where, but you can't walk to them and ask them to measure the distance.
So to go back to the idea of where the kids are at, in our circle we work with a first grade teacher, Joanne Sherman, and so that's great. We do first, second, third, and fourth graders. She knows most of the kids. It's a fairly small enough school, and she knows the curriculum obviously, so she knows where the kids are at, plus our own children are in, so that helps too. But it's actually been tremendously helpful to work with the elementary teachers. We have another first grade teacher and a kindergarten teacher who we also work with. And it's great because they know the children very well. It's just within the school. We have it as an after-school program. And so I'll come to the teachers with an idea like doing SET, and they're really good about saying, okay, but this is how we have to break it down so that the first and second graders will be able to get the ideas and move ahead with it. And that's worked really well. It's been a great team. I've really enjoyed it.
But also we take the kids that we know who are very high functioning, even though in the first grade, we move them up to the up with the older children and vice versa. So we have that flexibility knowing the kids. Because I think I've had all of them in my first grade math class anyway, so it really works out well.
I want to say a word of caution when you put kids' names into stories, because I just had a huge fall into this pitfall. All of a sudden, I was teaching 2-4-year-olds odd and even numbers, how to tell them apart. And they couldn't get the idea, and I think they were stuck with the words odd and even. So I said, all right, you, Sophie, let's use your name for odd numbers. We're going to call them Sophie. And for even numbers, we're going to call them Ogden. All of a sudden, this very pretty, very calm, very nice girl takes a building block, which we used for counting, and throws at me. And I say, what for? And she was so angry, she said, I'm not odd. So, before you use that name, take a look, maybe that word has a different meaning in common language than it has in math.
Comment on Owen's story. We had to do even odd with the total infinity, and kids are not getting this whole doubling idea until we say, okay, girls are in even rooms, boys are in odd rooms, or something like that. And then they understood the whole doubling of numbers in the hotel perfectly, no issues. So they have to have this concrete representation of it with their names, who's in what room, and then they could do it very well. So it's a very similar technique, and I think it's the same context.
Okay. I think we should thank the panel.